the ECM motor versus the PSC motor. Yeah, okay. So now the new furnace normally we use ECM motor. So that's normally we call it the DC motor. Yeah, so PSC motor we call it like the AC motor. Yeah, so it's a big difference there. So lots of guys said that the ECM motor is a save power than the PSC. I don't know. So some guy I saw the on the Google. So they said that the ECM motor not save money. Yeah, so not save the power. But I don't know if it's save or not. But we know is the ECM motor is a variable speed, and the PSC motor sometimes there's the different speed there too, but it's not a variable. Is right, like some PSC motor only 2-3 different speed. Yeah, but ECM is a lot of speed there. It's different. Yeah, it's from 0 to 100%. It doesn't matter what you want. Yeah, so energy saving. So you see, this is said is a save energy, but I'm not sure about this one. Yeah, so lower maintenance and a longer life. So they said ECM motor should be longer life or even double the life than the PSC, but the big problem is the control module. Yeah, the ECM motor. In fact, there's a look like a AC motor, and the end of the motor is a control module. Yeah, so this control module just changed the AC to DC. Yeah, so maybe the motor life, just like they said, is almost double for the PSC motor, but the control module is not. The control module so cannot last that long time, and normally, so like we met the trouble is about 5, 6, 7 years. The control module problem. So we need to change the control module. The motor is still okay. Yeah, so you can see there that they explained how many hours used. So, but I'm not sure how to explain that. So, but we should know is the ECM motor, the control module is more troubles. Increase the comfort. Yeah, so this one is really true. Yeah, so because normally we don't need the big air circulation in the house. For example, if we keep the temperature around 22 degrees, yeah, so for example, if the temperature is a little lower, 21.5, now we don't need the blower motor or the gas valve to open completely. So maybe we only need a 30%, is okay. Yeah, so the PSC motor cannot change the speed. Yeah, cannot change automatically. Yeah, but the ECM, so it can change the speed. So just make the speed is lower, and then we can feel comfortable. Yeah, so better air quality. Yeah, just like we said, this depends on the airflow. Yeah, airflow speed, like the PSC motor, if it's running 100% run. Yeah, so it's the suction is very big, so maybe makes dirt, dust everywhere. Yeah, the ECM motor, when they don't need, they just run very slow. So this makes the dust, the dirt is better than the PSC motor. So pressure relief valve. Okay, so this is a boiler or water heater. So they all has the pressure, they all have the relief valve, but boiler normally we call pressure relief valve. So that means, so if inside the the heat changer, the pressure too high, so it will relieve the pressure from here. Yeah, and the water heater normally we call pressure relief. In fact, normally it tests the temperature. Yeah, so if for example, some guys is leave the temperature control is too high. Yeah, so nobody use the water, and inside of the water is temperature too high and cause the pressure high too, and then release from the the valve there. So normally, so this relief valve connect the pipe should be connected to the floor drain. Yeah, otherwise maybe we'll flood the basement. Air scoop. So the water goes through here. So on the there's a baffle inside. So the air will go up and goes through this air bleeder. So that's the air separator. So just drain the air out, but keep the water inside. And if this one is pretty old, so it's a scale rust, something like that, there some of the water will come out too. So we can see the stain here. So normally, if like that, we should change this air splitter.
I'll make a quick note there too, Sam. So for those pressure relief valve guys, the discharge should be metal, not plastic. So every now and then you might come across one that is plastic. So just keep that in mind.
Oh, okay. Oh, so that's a boiler, right? So yeah. So for the water heater, we can see the plastic pipes there.
You bet. Yeah, so, for the temperature pressure relief valve, you bet.
Yeah. Okay. So this inside, we see the inside of the air scoop. Yeah. So there's like some baffles here, and keep all the air or bubbles up, and then goes through the the air bleeder to outside. Yeah. So there's lots of different type of air bleeder or air vent. Yeah, so you see this one is a little big. It's for boiler. Yeah, but if you have the air vent for the baseball, so there's maybe a small one, maybe only like this small. Yeah, so it's different style but same function. Yeah, so okay, air conditioners. So air conditioners is another big. We see the big equipment for the house, furnace, air conditioner. Normally, so most houses have both. Yeah, so for the air conditioner, so we should know there's two different parts. One is outside, it's a condenser, and one inside is a coil, or sometimes it's the other style, like a N or W, yeah, or slab. Yeah, so different style, but same function, okay? Yeah, so we should know there's a coil or evaporator just above the furnace and a condenser outside. Yeah, so there's two copper pipe connect these different parts together. Yeah, so one pipe is like a smaller size. Normally is not insulated. Another is a little big size pipe is insulated. That insulated one is the vapor pipe, and this is a liquid pipe. So, but for the heat pump, so maybe both copper line is insulated. Okay, so here I just explain the the principle. So for the air conditioner, in fact, just because inside the refrigerant, so R22, R14A, or the other refrigerant. So when the refrigerant, so they change the form from the liquid to vapor, or from the vapor to liquid. So they discharge or suction the heat. Okay, for the single air conditioner, so we just know the A coil here. So when the blower motor pull the hot air, so in summertime we should call the hot air from the return. Yeah, so the little warmer air draw from the the blower motor and push through the A coil. So when this little hot air through the A coil, it makes the inside the liquid refrigerant evaporate. So it needs a suction loss of heat. So that's called air. Yeah. So after the A coil, so the air is cooled and then blow to the every room. So after the the liquid refrigerant vapor and then suction from the the bigger pipe and back to the compressor. So compressor then press. So compress the the air so to the high pressure, high temperature air through the outside condenser coil. Yeah, so this outside condenser coil just keeps the refrigerant is temperature is lower and then condensate to liquid. Yeah, so the hot air then blow out to the atmospheric. So the compressor push the high temperature to the high temperature, high pressure vapor to the condenser coil, and then cool down, change to liquid, and then go to the A coil again. That's the circulation.